My name is Ryan Vanderwerf. I'm a solutions architect with the partner network at AWS, and I'll be giving you a little bit of a introduction to what RoboMaker is and kind of different parts about what make it work and what the AWS solution of RoboMaker does for you. And yeah, so can't wait to get started with that.
Hi, I'm Kevin Stanley. I'm a partner at OCI, a lead for the IoT practice within the organization. Just super happy to have AWS come and presenting on this topic. So it should be really interesting to see some cool stuff with RoboMaker, and that's sort of a great IoT platform. So I'm kind of excited to see that. So welcome. Thanks.
Awesome, and it's great to meet everybody. My name is Jeremy Wallace. I'm a specialist solutions architect, and I focus on the AWS RoboMaker service. So excited to be here today to hang out. Ryan's going to be walking us through this, but happy to chat.
Thanks,
Thanks.
guys.
Yeah, thanks, Jeremy. Jeremy, who can answer all of the hard stuff.
I don't know. That's we'll see. I'll do my best.
Okay.
See what curveballs people throw us. All right, so are we ready to get started with the presentation here?
Yeah, unless you want me to play some more music.
No, thanks.
Okay. All right, go ahead then.
I know. All right. Okay, so what do we got here? We talked about the online DDS training. Like you said, you can go sign up your company. You can join the AWS Partner Network, and it helps. We help sponsor things for partners like OCI to do cool things like this. All right, let's get started. What we're going to talk about today, we're going to talk a little, just very briefly about some robotics challenges before the cloud, and talk about a little bit what RoboMaker is and what it can do for you. Then we're going to go into a deeper dive about ROS and what ROS is, and how we use that for application development with RoboMaker, and then how we can run some simulations with RoboMaker and what those kind of use patterns look like. And then I'll show you a demo about using the Cloud9 IDE and running a simulation. And we'll wrap it up. We'll talk about what ROS extensions and things we've added to help robotics engineers get more value out of it. And then I've got a few hardware options there too that you can get kits for at different levels of what you're trying to do. And then we'll have a wrap up and try to answer questions here. All right, robotics is really becoming a bigger thing and accelerating certain key industries. It's definitely going about a fundamental change with collaboration, autonomous mobility, increasing intelligence, and ID TechX says by 2023, it's estimated that mobile autonomous robots will emerge as a standard for logistic and fulfillment processes, and by 2030, 70% of all mobile material handling equipment will be autonomous. And so there's robotics that can handle all these different types of industries, like retail, logistics, agriculture, oil and gas, health industry, and things like that. So it's a lot of opportunities to use these kind of things, and getting this technology in people's hands to help make things is where we can really help you out here. So some of the challenges of developing and deploying these robotics, you do really need a multi-domain expertise on how to build robots, which most people don't have. You need to be able to have iterative development and get it right. You've got this hard task of configuration management and kind of trying to tame this beast of having different configurations all over. Building your own framework for deploying them and managing all these robots can be tedious, hard, time-consuming, and kind of slow your productivity on getting these things out. And then another problem is if you don't have any way to simulate all of your robotics before you actually put your hands on the physical hardware, you really have that limited testing. And if you don't have enough hardware, some of this stuff's pretty expensive. You're not going to have enough engineers hands-on testing this stuff, because if you don't have a way to simulate, then it's going to be a difficult journey ahead. And again, once you deploy these robots, and you've got different kinds of robots, deploying and managing those things can be really difficult. And so RoboMaker can help in that area as well. So really, we're talking about robotics application development here. We've got this sort of cycle here of we design and develop them, and we need to test and verify them first before we try to put it on physical things. And then we want to deploy and update it to physical things and make that process as easy as possible. And then continue that virtuous loop here of deploying, updating, designing, developing, and keeping that cycle going, or keep your quality up quite well. And so what we have with RoboMaker to help you with these things is we've got a cloud service that basically simulates and deploys robotics applications on the cloud scale. And what that means is we have special integrations with ROS to help with AWS. We've got a cloud-based simulation environment for you to be able to test your robotics projects. And then we've got a framework for deploying and managing your fleet of robots for you, and greatly simplifying that task instead of all that heavy lifting yourself. We're doing that for you. And when we can deploy and update at cloud scale, we really have that ability to control the deployments. We have a visibility of the health of the robots. Since we're talking to the robots, we can see what their health is. We can monitor what's going on with it. And then we can deploy across multiple robot brands also at once. So it doesn't have to be all of the same thing to be able to do this. All right, so how do we deploy updates? So basically what you need to do is we support robot registration over the air deployment with RoboMaker. And so you can register these robots in the RoboMaker fleet management. You can organize them into different fleets. You can deploy a robots application into a robot fleet securely through just a few clicks. You can do some conditional over the air updates, and coming soon, there's fleet monitoring, alerting, and field rollback features in case your deployment didn't go well. So when we test and verify, the key part of what RoboMaker is giving you is this easy way to simulate your environment. So while you're developing your code, you can build and deploy that to your simulation and run it, and then show that in real time. And I'll show that to you later in a brief demo. You can also test different kinds of scenarios, and then you can have different ways to drive optimization in your project. So when you're using a simulation to replicate your environment and different variations environments might have, it can really optimize this usage of resources for your robots. And again, as part of the simulations in the cloud, we've got pre-built virtual 3D worlds. You can bring your own. There's no infrastructure to manage, configure, or provision. So when you want to click to run a simulation, it's a simple couple of clicks and you're up and going. You can run a bunch of simulations in parallel if you'd like to do sort of mass testing. And you can also auto scale based on how complex your simulations are. And again, all of this is a pay-as-you-go simulation on resources consumption. You can also do regression testing with a CI/CD integration. And so one thing you can do as far as testing your robots before you actually put it on a physical one is you can go through a regression test suite, either by using recorded ROS bags that you keep in your simple storage service S3 buckets, or you can have some physics-based simulators as well. You can do large scale concurrent simulations, and you can trigger them in a batch using the RoboMaker simulation API. So we'll give you a set of APIs that you can call and spark different simulations from your CI/CD system, whether that's code pipeline or another tool that you might use in-house. And you can automatically really advance these successful simulations up to different code branches automatically through something like code pipeline and code commit and code build, to where you can have stable night releases published for your robot, and then have other people try it out as well to physically deploy that in the robot if they want to. Some customers that are using this service, iRobot is one of them, and they're using it to accelerate their regression testing. And kind of the need here is that test coverage is for different kinds of floor layouts and different kinds of scenarios for running these robots is, tedious, time consuming, and slow. So they needed a way to speed up that way to do any kind of regression testing and make sure they haven't introduced bugs into the robot software. So really this challenge is it's time consuming, and they can only test so much if it takes so long. So the solution was that they built a CI/CD pipeline for large scale and automated testing using RoboMaker simulation service. So they have 40 automated tests that run each code commit, and more than 500 automated tests for each release candidate that they can just run at the click of a button. It's much faster testing and release cycle. And for them, it turned out to be 1 hour versus 3 weeks for testing 70 complex localization scenarios. That's quite a bit of an advantage there of time saved. And these are the different kinds of layouts that they have to test to make sure that they haven't introduced any kind of bugs into the robot vacuums. One of the advantages of doing this is that you can simulate multiple robots in a fleet. You can connect multiple simulations to a central fleet management software and test these multi-robot scenarios if you want. And you can also simulate inter-robot interactions or missions across different robots. Another customer that's had success using RoboMaker is Bastion Solutions, and they're using that to simulate multi-robot fleets. And their problem was they had to orchestrate this fleet of robots, and getting all these deployed is very difficult and time-consuming. So they needed to test 8 different robots in a test lab, and that's their limit of physical robots. So when you can auto scale simulations, you can do much more than that. So their use of RoboMakers, they're enabling a simulation of multiple of 35 plus robots instead of 8 to 10. And again, they're doing all of this testing without needing physical robots, so they can accelerate all of that benefits there. Another customer that's using this, TAKENAKA, they're using for smart construction robots. And one of our partners is also developed that. And their problem is they're trying to, they couldn't even implement a fully autonomous robot as they did not have a tool to train the robot before the operation, the construction site, because of the changing build architecture that happens so often. And when the automation, they needed to reduce simple tasks, repetitive tasks, and unskilled things that humans don't need to do anymore. So they're making use of the RoboMaker simulator to pre-train a construction robot before it's real field operated. And you can do that inside of their pre-train different kinds of models and then deploy those out to the robots and then run them after they're trained, which can save quite a bit of time of training itself even. So again, their benefit is simple tasks and repetitive tasks that unskilled workers don't need to do are done by these autonomous robots, and they can do cleaning, delivery, and markers in the field. Another customer that's using RoboMaker, AppPod, they've got a digital twin environment for RoboMaker users. So they've made something called a fusion data streaming hub called IntDash, and they have a edge agent and server APIs and visualization dashboard for industrial fusion data streaming. And one of the things is that gives this really good telemetry and teleoperation. It enables customers to rapidly develop telemetry and data acquisition. And they also create machine learning pipelines. So in Dash, they can do data acquisition of all the ROS messages and then orchestrate all of that data for machine learning on SageMaker. Another problem is that people run into is that you're trying to manage multiple robots across different brands, and enterprise customers really are unable to easily manage this fleet of multiple AMR brands of robots. And AWS RoboMaker makes that simpler for you because you've got a unified interface and you can orchestrate all of your robots and share maps across multiple brands. All right, so that's kind of a how-to or what is RoboMaker. I wanted to dive a little bit deeper here. If you have questions, go ahead and send them in the questions thing, and we'll try to answer a lot of those at the end, and then I'll jump back to whatever part you had questions about. All right, so one of the things that makes these robots work is a system called ROS, or the Robot Operating System, and this really gives a many-to-many publish subscribe framework. So a robot can talk and send messages across the different components of it and communicate with itself. It's an open source project under the BSD license. It's got a very large ecosystem of packages and tools, and it's the largest active developer community for roboticists to use. And it's used in both research and commercial applications, so a lot of things in academia as well. And going forward, there's which OCI is helping work with on ROS2, is there's been a renewed effort to really make these commercial applications that have reliable and security and consistency in mind. And we have a middleware interface based on DDS, which is exactly what OCI has their training class on. And this has got multiple industry support from Amazon, Intel, Bosch, Microsoft, LG, Toyota, Research Institute, and others. So this is really taking the ROS project to the next level. And this is available on, which is called beta right now on AWS and RoboMaker. Jeremy can elaborate a little bit more on that, but from what I understand, it's basically GA, but it's obviously not hardened, ready for production like as many people would want it to. But if you're familiar with all those risks, you can certainly consider it GA in that respect for the dashing release. And then there's an upcoming release called Foxy that's coming out in a couple of weeks or 2 or 3 weeks. And AWS will follow RoboMaker support a few months after that because they have to update quite a bit of things in addition to that with the ROS extensions. All right, so how's AWS helped with ROS2? So they've contributed in a number of fronts around quality of service, features or topics, cross-compilation tools. There's a ROS2 launch sandboxing extension, and they've also helped fix security bugs with secure ROS2 improvements, as well as create runtime analytics tools to address in some thread sanitizers, as well as creating and maintaining RCP PUtils core package. So AWS is very interested in contributing to the open source community around ROS2 to make it a better product for everyone, as open source should be. All right, so let's talk about how this thing works and how it interacts right here. So normally you have a developer and a physical robot, and that's kind of the end loop there. So where RoboMaker comes into play here is when you're adding AWS Cloud, we've got a RoboMaker service. And what that's giving you is a web-based IDE for developing your code. And you've also got, inside of that IDE, the ability to run simulations on your project. So you can basically iterate, build and package your code, and then run your simulation, and then see how well it performs, and then rinse and repeat until you've gotten where you want to be. And one other advantage of using RoboMaker is that it's tied into the AWS ecosystem. So we have direct support for CloudWatch. So your robots themselves can interact with CloudWatch. They can interact and send a video stream, like if the robot has a camera on it, it can send that to Amazon Kinesis video streams. We can also use Amazon Lex and Polly, so you can have the robot talk and understand you and translate speech back to text that can then parse that out and formulate a response. And so you can have truly interactive robots with all these services that would be connected into the AWS ecosystem. As part of that, RoboMakers also give you the RoboMaker fleet management. So once you're ready and you've simulated your robots and done your development and you're ready to try it on a physical device, they have just a few clicks deployment for pushing your project out to a physical robot.
Hey Ryan, we have
Yes.
a question. We actually have a couple. So is this an okay time?
Yeah, sure. Let's
Okay.
break it up here.
All right. So the question is, has there been any use of robots or RoboMaker to emulate tasks normally performed by humans, such as shoppers in a store, pedestrian movement at a university, theme park, etc., to help reduce the testing of security and other processes where the activities of humans can be simulated before live trials?
I don't know of any specific use cases, or at least that I could share. I don't know if Jeremy knows of any.
Yeah, absolutely. I think this is one of the areas where running your simulations in AWS and in the cloud can provide some very interesting benefits. For example, when Ryan mentioned the multi-robot example that Bastion Solutions is using, what we're doing there is we have multiple in parallel running RoboMaker simulations, and we aggregate those all into a single simulation plane. So you can really horizontally scale the number of simulations that you're running why this is interesting is because we're using Gazebo plugins to dynamically alter that consolidated simulation, and so that we can interact with the multiple robots running in the same kind of fleet simulation environment. So you could see a very similar workflow if you had things like humans or different dynamic changes into environment. Maybe a box falls off of a shelf and then a robot has to react to that situation. When you're in the cloud, what you can do is have interactions with services like AWS IoT, which is an MQTT broker to easily publish and subscribe messages between AWS invoked actions and running the simulations. So you could dynamically change your simulation environment based off of either routines that you've defined or just kind of manual. If you have your QA team that's kind of running through a simulation and then adding in dynamic conditions that are common in a given robot kind of testing workflow. So yeah, that's absolutely possible and definitely a good set of test use cases.
Awesome, thank you. And so we have a hand raised from Liliana. Liliana, you are unmuted and you can ask your question. Or did you maybe have your hand raised by mistake? All right. Well, we will come back. If you decide you want to ask your question, you can type that in and we'll read it out loud. Okay, go ahead, Ryan.
All right. Thanks, Jeremy.
Not a problem.
All right. So a little bit about RoboMaker architecture. So we've got our development IDE. Our robot applications, once we build those, are deployed to a simple storage service or S3 bucket, and they're packaged up and put out there, and then that's where the simulation then picks that file up and then that packaging and runs those simulations. We have 3 different ways you can view your simulation. We've got Gazebo, RViz or RQT, so depending on what you want to develop your simulation for. The one I'm going to show you today is running Gazebo, which is a pretty popular one. And then while the simulation's running, we be sending data to CloudWatch to monitor what's going on. And again, things like Kinesis video streams. And then all those simulations, when your simulation's done, all of those files are put out in an S3 bucket that you can specify and get to those later, including your ROS bags. And then once we're ready to deploy, we can deploy our application using the RoboMaker Fleet Management, which is, I believe, under the hood using IoT. And that's how you can make, like Jeremy said, different robots interact with other things. So if you want to send a message to a topic, and then you can, inside of the IoT console, you can make it react to that. If you get a certain message, take an action, and then go do something on AWS, either make a change or signal something else to happen. Sky's the limit there. And here's sort of a recap of the architecture. So these are all the different services we can tie into. So we've got Lex, Poly, you can do recognition, right? So once you've got that Kinesis video stream coming in, you can be using recognition on that video stream and then making the robot identify objects and figure out where the bounding is on where where it's seeing them at, and then take some action on that based on what it's seeing. And you've also got CloudWatch metrics, you've got your CloudWatch logs, you've got your build tools, your IDE, which is all web-based, so you don't need to buy or purchase any kind of license for anything. We've also got machine model training abilities, and we've got our interactive simulations, we've got regression testing, and when we plug it into the CI/CD pipelines, we can do that automatically. We've got the robot registration and the deployment and the monitoring and the management. So this is what RoboMaker is doing for you. Which is quite a bit of heavy lifting that you would no longer have to do. And then you can just really focus on your core task of building your robots. And then below that, we've got our cloud extensions. So that's what enables all these AWS service access for your robot. And those are extensions for ROS. And that's one of the reasons why, after a release of new release of ROS 2, these things may have to be updated and tested and make sure you're getting a quality experience. with those. We've got our development environment, which is a Cloud9 IDE, and then our simulation environment and our fleet management, and that's all running on top of either your choice, ROS or the ROS2 dashing.
We have a question here,
Yep.
right? So the question is, can simulations that are created and placed in S3 buckets have an aspect of randomization in them to create robot scenarios that vary enough to simulate human activity to some degree? Also, is there support for communications between robots that can be reacted upon in some way in a simulation?
Yeah, so as far as let's pack out I'll pack out the last part of the question first, which is how do you make it interact with other robots? And you absolutely can. So there's a message bus, the MQTT broker, happening on the robot itself of everything that's going on. And so with your AWS IoT platform, you can register actions that happen when a certain message is received to trigger another bit of code running, whether it's via Greengrass running on the robot, or is something externally happening on the AWS account to trigger different activities. So as these robots process messages, they can also receive messages and then take actions all through the IoT console. Jeremy, do you have anything to add there? I think.
Yeah, I guess the only thing I would add there is, so ROS leverages ROS topics as a methodology. I mean, really, if you think of ROS, big part of the benefit of using ROS as a framework to build your robot applications is the messaging components that they have. And so what Ryan was referring to there is the ability to bridge those messages over an MQTT broker, which is a really great way of decoupling some of those messages that you're sending to robots running in a simulation. However, you could also use, there's something called ROS Bridge, which is a ROS package you can use to connect two different robots that are running in two different simulation jobs. And so you could, the cool thing about RoboMaker simulation is you can have it run within what we call a virtual private cloud, or VPC. That's your own private networking space within AWS. So what that means is you could have your own process running on a EC2 instance in a VPC that's also communicating to that simulation job. In RoboMaker simulation, you can open up ports and define which ports are open for communication. So there's a lot of flexibility in which you can use many different protocols as mechanisms to communicate between robots. As far as randomization, I think that's really interesting. What we've seen is a lot of customers, the best way to simulate a human doing something is to have a human doing something. So if you have a QA process and your QA engineers are running through some of the test suites to ensure that your code is ready for production, what a lot of companies do today is they just have a human that kind of adds in random things. However, I think there is a lot of interesting work being done around using things like machine learning to dynamically generate conditions that you could run within a simulation. Secondly, when a little bit earlier Ryan mentioned running a CI/CD workflow and doing automated testing, similar to what iRobot does today with RoboMaker. And we actually have a blog article out that you folks can go check out on our AWS Robotics blog around this topic. And in there, we have something called the scenarios.json file. So that's a description of a set of conditions within a simulation through setting environment variables. And so why this is interesting in this particular question is that you could define hundreds of different conditions, and then with this solution, it'll run 100 simulations at the same time that cover all of those different situations. So let's say you've heard from the field that these are the human actions that cause problems with your robots. You could capture all those edge cases and even potentially unsafe conditions. You could capture all of those and then slowly build up that set of automated tests that you run for every single code release. So that could be, again, manually captured just through feedback and through observation of how your robot is interacting with the environment around it. But it also could be generated through some randomization of environment variables themselves. And that would be interesting, not only from just a random generation of values, but you could also do things like machine learning with something like SageMaker to produce the most realistic situations. So a lot of possibilities, but that's a little lay of the land of some things you can do.
Awesome. Thanks, Jeremy. Nikki, do we have any more questions?
Yes. Nope. Nope. He just said, George said, got it. Thanks.
Okay.
Oh, wait. We do have one in the chat. Okay. Where in the architecture is the management of security? How is communication and sensor feedback validated?
So the IoT core is running on the robots itself, and that's all handled with certificates. So in IoT, you can create a certificate and then install a certificate on the robot. There's also ways of provisioning those. I don't know if you're familiar, Jeremy, with how certificates are automatically provisioned on robots.
Yeah, so the RoboMaker fleet management uses AWS Greengrass under the hood as this mechanism to deploy and launch your ROS applications on your robots. So when it comes to provisioning those, and so it uses X509 certificates to connect to the AWS IoT device broker, which is in the cloud. And then essentially what's happening is you have some information that's synced between the cloud and the robot that then would invoke a deployment action, let's say. So those certificates, you can either provision them in the cloud and then copy them on your robots. But there is also a few different modalities. There's actually a workflow, and this is available on our AWS IoT solutions for provisioning certificates automatically during a manufacturing process. So if you wanted to do that at the manufacturing, at your factory, when you're building your robots, you could have a process that would automatically provision those certificates there. And then there's also a mechanism for just-in-time provisioning of those certificates. So with, I don't know how deep we want to go here, but happy to also do a deeper dive one-on-one later. But when you're producing certificates just in time, you usually want to disconnect the certificates or decouple the certificates you're using for that Greengrass software that's running on your robot and managing all those over-the-air updates from the data plane. So that's your sensor data that you're going to be capturing and then streaming into the cloud. So you'd have two sets of certificates. And so that second set of certificates that's doing this sensor data capture, those you can provision on the fly, which means that you're going to have a different set of certificates when you start sessions of communication. So I think that's going to give, it gives a lot more, I guess, from a security perspective, it's a lot more dynamic. And there's a couple of solutions there that I'll go find the documentation and throw the links into the chat.
We
Awesome.
have one
Thanks, Jeremy.
more question. It's any insight into the pricing and cost model? Is it priced based on the underlying compute used, or does it have a PaaS or SaaS service-based pricing?
So it is only RoboMaker itself doesn't cost you anything, but you're just paying for the underlying services it uses. The only exception to that is when you're running simulations, because it's doing all these things for you and you can't see them. There's a price per simulation unit, which is broken down, and so you're paying for that over time based on how many resources your simulation is using and how long it runs.
Awesome, thanks. No more questions right now.
All right, let's get back into it here for a little bit. All right, so a little bit about RoboMaker in operation. We've got our security throughput. Jeremy talked about certificates and different ways you can provision those through our IoT platform. We've got a consistent end-to-end development framework. We've got DRESS ROS interaction with AWS services. We've got a good simulation of robot applications. And again, we've got fleet management of robots. So all of those things are really being handled for you. So I'm going to switch gears real quick to show you a little bit about how the development environment works. So when we want to design and develop these robotics applications for things like ROS and Gazebo, you can really follow this agile development of the robotics applications and reuse software and have iterative development. So based on the IDE in your development environment in Cloud9, you've got two different, this is traditionally how they're split up, a simulation and then a physical robot code base. Depending on what you need to do there. And so you can develop and work on those inside of Cloud9 in the RoboMaker environment. And then that simulation app goes to an S3 bucket and your robot app goes to a bucket, depending on what you want to do. So those get all packaged up and then you get to run your simulation as you build. So all directly from the console. You can even get a shell script prompt from the IDE of the EC2 instance Cloud9's running on. You can do your build right there and it gives you a build window of what's going on. You can also package it up and then you can deploy and run a simulation from there. Here's this is a bit of a busy slide. I apologize for that. This is an example of a CI/CD workflow here. And I'll just go over this briefly here as far as we've got a Git repository or AWS code commits. Traditionally, the flow would be your starting from your feature branch, and you want to run that through your code pipeline from a Git hook for a merge, and then push down code build or build in for a code for a ROS container. Run some step functions in Lambda to run multiple simulations if you want to do that, and then check your status with a step function. You can wait until it's done running the simulation, and then after that, it can go ahead and if things pass, you could push that into, say, your master branch if that's the style you're doing, and clone that on a Git hook, and then you could also have the pipeline continue and build and bundle that for a ROS container, store those in S3, and then go on to physical testing and delivery for your robot, whether that's a manual deploy or an automatic deploy or whatever you want to do, and then it'll click and deploy to your fleets. So you can kind of bundle it all up there into one nice CI/CD environment and have the power of that testing and regression testing that may not been really easily available to you before. All right, so how do we run simulations? So there's a couple different ways. What happens is when you start a simulation, it creates a simulation instance and pushes that package to an S3 bucket and then runs it. And then you can run your simulation in either Gazebo, RViz, RQT. You can also see the terminal of the robot that's running the simulation, and you can access the terminal directly, get to anything that's on the file system, and check anything you might need from there as well. So it gives you the power to see visually as well as textually what's going on. And of course, we've got our CloudWatch integration, and then the logs get put out on S3. One cool thing is that Jeremy touched on is that we could run all of this in a customer VPC. So you can create an elastic network interface and have a connection from your robots directly in, like you said, sort of poking a hole and opening ports. So you can access everything on your private network and make things communicate with each other that way. Even go out using a NAT gateway to the greater internet if it needs to. And through all of that, your robot can access those AWS services directly, which means recognition for image recognition. You've got your Kinesis video stream, your CloudWatch logs, all those ROS extensions that we've added will help you out there. And then when we're done, we've got our simulation logs stored in S3, and we've got our ROS bags also stored in S3, and you can play those back later if you want to run that again. So how do large-scale simulations work? talked about that briefly about how that's before things like RoboMaker, it was kind of a tedious, hard thing to do. And now we can do multiple simulations quite easily, either using a CI/CD pipeline, or you can just manually launch them if you want to, and fire up as many as you so choose. And that can all be, compressed down into one simulation, one master simulation that runs all these other simulations, and kind of create your little ecosystem of robots. And then we can collect all of our metrics with CloudWatch. We've got all of our log files stored for all of those simulations. You can have a single pane of glass to view all of those things. And so here's what a multiple robots and simulation application architecture would traditionally look like. So you've got a simulation job, you've got your consolidated robot data, you've got your ROS extensions, talking to the AWS cloud. We've got the IoT communication layer through the IoT platform service, and we could probably have a whole nother talk on just IoT, AWS IoT services and Greengrass, but in summary, we're basically translating those messages over to MQTT messages that can react and take actions on things. And in this case here, we've got a simulation job running. It's like a spawner and mover. And then we've got all of our extensions and multiple jobs running from there. And this is what a simulation in Gazebo looks like. So one of the things, I don't know if anyone's familiar with AWS Deep Racer, the league where you can race cars using reinforcement learning. And when you run a simulation for that in the console in Deep Racer, what you're really looking is these, you can see this may look familiar, you're looking in simulations with Gazebo and RoboMaker behind the scenes. But that's how you're training your car to go around and around in a track, right? You're doing that training ahead of time, and then you're deploying that trained model out to a robot with just a simple, at these events we use usually thumb drives or an S3 bucket, and the track boss person puts that on a robot, and then we have races around a track to see who can get the best time. So there's a lot of competition around that area. If you're interested in getting into Deep Racer, I highly recommend it. If you go to aws.amazon.com/deepracer, you get a lot more information there on see if there's a local league near you where you can participate. So I'll talk a little about the service extensions. That's what's giving all your power to connect to the AWS cloud from your robots. We've got support for ROS Kinetic, Melodic, ROS2, dashing. We've got native ROS packages for the following services. So we've got Amazon S3, we've got scalable secure storage there. We've got CloudWatch for logging and metrics. We've got Amazon Rekognition for our image and video recognition, and Kinesis for video streaming, and then Lex and Poly for the voice recognition and text-to-speech conversion services. So you could make very interactive robots that way.
We have a question, Ryan.
Yeah.
Is it possible to run simulations not in the cloud, but locally?
I do not believe so. Do you know, Jeremy?
Yeah, absolutely. So the simulation software that we use in AWS called Gazebo, and Gazebo is a very common simulation tool that folks use with their ROS applications. You wouldn't necessarily need to have a ROS application, but the same open source robotics foundation kind of manages and builds both of these tools. So that tool Gazebo, you can run it on many different flavors of Linux. So you could run it on your local machines, run your simulations locally. Some of the limitations though of running locally is that you're only going to have as much compute power that's available on your laptop. And secondly, you wouldn't necessarily be able to horizontally scale out and run, let's say, 100 or 1,000 simulations. So we see that workflow a lot, is that people will use their development tools that they are comfortable with locally on their machines, do some quick development just to see how your code changes are resulting in changes in a local simulation. And then once you're ready to push your code changes, that's where you can have an automated workflow in the cloud that would spin up a whole bunch of different test scenarios. But absolutely, you can run these locally.
Now, Jeremy, when you're running those locally, do you have access to any AWS services if your robot takes advantage of those?
That is a great question. So if you do want to connect with AWS, the nice thing about the simulation service in AWS is that you can associate what we call an IAM role. It stands for Identity and Access and Management, and that's going to give you the ability to easily allow access to many different AWS services from that simulation running in the cloud. So that's a really easy way to connect with AWS. However, if your local application was you want to test that out and connect with AWS services, you need to have either a local access key ID and secret key configured in your AWS command line interface, or a set of access credentials in an environment variable that your application can reference in order to use any AWS SDKs that you might include within your ROS applications.
Another question, can you provide an example or two of what CloudWatch would log from a simulation versus something like a typical EC2, CPU, memory, disk, network IO, etc.?
Do you want to take that one, Jeremy?
Absolutely, no problem. Yeah, so the CloudWatch, what's kind of cool is not only are you able to run simulations in the cloud and deploy applications to robots, but the AWS RoboMaker team also manages a set of open source ROS packages that you can easily include with your applications. One of those ROS packages is for CloudWatch. And so what that enables you to do is actually pipe, and so right in front of the screen right now, what Ryan has is perfectly timed for this question, which is a set of ROS topics and nodes that are going to be publishing over those ROS topics. So what's cool about CloudWatch logs is it'll actually take the data that's coming out of those ROS topics and then pipe it into CloudWatch logs. So you can see this being very useful. If let's say you had 100 simulations running at the same time, you're not going to be tailing the logs that are running on each one of those simulations. You'd either you'd have like one of those matrix style screens with like 10 monitors and you're really good at seeing them all, or what you could do is just enable in the simulation service, you could have those logs get piped into CloudWatch logs, and then you could do an easy keyword-based filter through them and find the information that you need.
Awesome. Thank you, Jeremy.
No problem.
All right. If we don't have any other questions, we'll move on. So Jeremy already talked about this slide here, which is the extensions and operations and how all these topics are publishing this data. And that can go into things like CloudWatch and see what's going on there.
We have a comment, and that is, I don't even see the code anymore, the matrix.
Hey Ryan, I was just thinking the other benefit of the simulation service when it comes to CloudWatch is it will automatically pipe the ROS out topic, as well as any system out logs that you have in your application into CloudWatch logs. So let's say you had a failure in your simulation. You could go into the CloudWatch logs that are by default defined. And so let's say you weren't using that ROS extension, you just ran a simulation. You could go into the CloudWatch logs and you could see what's being printed out as log statements with your ROS application in there. So that's another kind of managed benefit of the simulation service.
Awesome. And one of the things Jeremy had talked about here is how do you make your robot work with whether you've got stored credentials or temporary credentials, if you're running it locally in a robot or running a simulation locally, like Jeremy had described. You've also got, your CloudWatch, everything piped in from that. So I think we've done that. So let's look at the just a brief demo here. Let me go back and let me share one that I've got started up. All right, does everyone see this okay? So what I've got here is the Cloud9 IDE for a sample project called JetBot. And this is available on RoboMaker Workshop's website, which we can provide that, drop that link in later. But these are all publicly available. So I've got one here called JetBot, and we've got two different robots that we can run in here, CircleBot and TeleOpBot. And this is the development IDE that you can use. That's just comes with it. If you have your own set of developer IDE tools, you can use those. But we've got our project split up into our robots code and our simulation code. And we've got all of our source inside of here. And we've got a README about how to get all these projects up and running. So we've got our applications for running the simulation. So what I've done is that you can actually say build, and I can build my project here. I can bundle my project up, and then I can see what's going on here. So here's one of my bundles here, and I've got a bash prompt to my development environment here too, so that I can completely interact with as well. I created a simulation a little bit ago, so all we have to do is say run, and then go to launch simulation, and then this project has two different bots so that I can run. So I've got the circle simulation running, and it's just a robot basically going around in a circle. So what happens here is that we can see from the RoboMaker console. So when you go into RoboMaker, this is what you'll see. And we can create a development environment, and we can specify which ROS version we want our development environment for when we go ahead and create one. And that's going to allow us to tie into specific roles that are allowed, which ROS distribution we want, any private networking features that we want to enable to make it talk on your company's private network. And then we can go ahead and launch that. So I've already got one here going. It takes a little bit to spin one up. So this one I showed you, we've got going on. So I started a simulation job right before we got into this, just so we didn't have to wait. And so this is where you can see your simulation jobs running and get a summary of what they are. So I've run one where I let it go to completion, and the other ones that I've just stopped because I was done using it at the time. And we can go ahead in here. We can connect to our simulation. We've got a unique ARN for it to connect with it. We've got a set of simulation tools here. This one is meant for Gazebo, but I can also go in. This is pretty cool. I think I lost my Gazebo. No, my Gazebo's running here. So I spun this one up already. And so we can see our robot here running in Gazebo, turning around in a circle basically. But I can change my viewpoints for it. I can change my camera view. I can give all these different control aspects to it and see the lighting of how things are going. And I can see how long the simulation's been going for. So it's pretty neat stuff. You can also go in and obviously, if you're familiar with this one, you can edit it from in here as well with a model editor and a building editor. So yeah, so we've got a simulation running. We can see what it's doing. Another thing that's pretty neat is that you can actually launch a terminal here and go into a shell access to the robot itself running in the simulation. And so I don't need anything configured on my machine to run this, which is pretty slick. Just gives me a terminal prompt. And so now I'm actually on the robot itself while the simulation's running, and I can see what's happening here. So I can see where it deployed to. This is my workspace for the robot that deployed, just like if it were a real one. And I can go into my bundles. And we can see all these things were deployed automatically to it. So we didn't have to do all this stuff. But you can go in here and troubleshoot anything that might be going on here with your robot as well. Just kind of a nice little tool here without having to do specialized networking or VPN access to get to a shell screen on the robot itself. We've also got some stats here. These are pulled from CloudWatch. So we've got how many simulations units we're using. So this will bill us while we're running a simulation. So this particular one's consuming almost 9 simulation units. So I'll be billed on that. And then I've got other information about the configuration. I can go in to look at the logs and metrics in CloudWatch directly from here on my simulation while it's running. I don't have it deployed to a physical robot because I don't have one of these things, but if you did, you could tie it in that way. So here's my circuit simulation here. So I'm running the circle robot. This is what version I'm using. All that's being packaged up and deployed for you. So it's super easy to deal with and manage. Also, we've got some resources over here. We got a bunch of other applications that you can do. So if you want to try this out yourself, we've got simple as a hello world to just get started using the service, and then graduating up with robot monitoring and seeing how that works, person recognition with recognition, all the way up to self-driving and self-reinforcing cars, which is basically what Deep Racer is, and then object following and things like that. So we've got a lot of cool sample applications that you can try out here on the RoboMaker service. I definitely recommend you give those a try. But and then also under fleet management here. So if I've got physical robots, they would appear here. And if I want to manage those into fleets for easy deployments, I can do that here as well. And I don't have any robots to make a fleet with, so I can make a test one. I can't use the space. We can tag our resources as well so we don't get lost in those things. And then we can see how many robots we have, what their sync status is, whether they've registered or not, and what deployments we have going on. So we've got the single pane of glass to view all your robots going on at once. And then as well as you can create an actual deployment here and manually deploy things to a fleet. And then pick an application. I don't have any ones defined right now. I don't have a physical robot. But we can do all these different deployment settings here in real time as well without having to even set up a code pipeline build or anything like that. So that's in a nutshell a demo here. Does anyone have any questions or particular little bits you wanted to see?
I don't see any typed in right now, but I will take this opportunity to remind everyone that if you are interested in entering our raffle for the live instructor-led OpenDDS training next week, you can drop your name in the Q&A box and I'll enter you into the raffle. So we're getting close to time, so we'll draw names soon.
Okay.
But I don't see any other questions typed right now.
All right. So we're just about wrapping up here.
Wait, we got a couple. Maybe there was a little lag.
Oh.
So question. Can you create an application for a specific brand robot, such as Marty THR robot or NAO? Is that NAO?
Now? The SoftBank Now. Really cool robot, by the way. You can use it to do to play soccer matches and stuff. It's a big cool thing to see at RoboCup every year. Essentially any robot that has a ROS implementation. So if there's something called the URDF file or Universal Robot Description file that defines a robot. If there's a URDF file and a sample ROS application for any type of robot, then you'd be able to run that in a Gazebo simulation and likely in a RoboMaker simulation as well. It depends on that. But if you can go check it out too. ROS has a list of robots, commonly used robots on their ROS.org website, where you can find some more information about that.
Cool. Next question, is there some kind of agent that runs on the robot for deployment?
Yeah, so we're using AWS Greengrass is the agent that runs on the robot for deployment. And that's how all the deployment's handling with the credentials set up, like Jeremy had said, the X509 certificates. That's what keeps the communication secure between your robot and the cloud.
Okay, next question. Any plans to support ignition simulation since Gazebo is coming up to EOL?
Yeah, that's a great question. So in RoboMaker, our goal is to support the various simulation tools and robot application frameworks that customers are using. So as new capabilities come out in this ecosystem, our goal is to try and support them all. I don't have any specific information about that I can share in this forum today, but you can kind of deduce that as we support ROS2 and the ROS2 ecosystem, and as Ignition develops as a core simulation platform for ROS2, then we're going to continue to develop functionality in that with RoboMaker.
Excellent.
Alex, you are unmuted. You had your hand raised, but you'll probably have to unmute your microphone if you're interested in asking a question.
Hey, sorry about that. I think my pocket must have hit the raised hand button.
Oh, that's okay.
No worries. All right, well, let's get to wrapping up then. Let me jump back to the slides here. So I've showed you some of the links that you can go to from the RoboMaker console directly. These are some of the sample robot applications, the same things I showed you. You can learn, try out the robots and just running the simulation yourself. You don't even need access to hardware robots to try it out. So I strongly encourage you to get signed up and try those things out. We do have some recommended sort of kits, I guess you'd say. So there's a Qualcomm RB3 robotic kit, and Intel Aeon one, and an NVIDIA JetBot kit. So here's some links to where you acquire these robots and some pictures of kind of what they look like. If you just want to get something going to try this out, definitely recommend that. So the JetBot kit is what we're seeing, what I was just showing you in the simulation, that's the JetBot. So that's the computer simulation version of seeing it. And then there's here, the slide is what it looks like in real life. So you can buy one of those and try it out yourself and do the full cycle. Strongly recommend it. It's a super fun area to work in. And if you want to get started on RoboMaker, just go to aws.amazon.com/RoboMaker. And from there, you'll get access to tutorials, developer guides. There's blog posts. I'm sure Jeremy's written quite a few of those. And get started and going on this thing. All right. Any final questions before we close out?
Thanks, Ryan. Yeah, let's see those questions before we do the raffle. Question: any advice for a beginner who is starting to learn robotics, robotics applications?
Yeah, I'd get on the console and try it out. Buy something like a JetBot and get started. Try it out in the simulator first, though, before you go plunk down money on physical hardware. I've done different robots that aren't ROS robots before. They're very simple, like self-driving car type of things, but this is a really good framework to get into where it's very organized and not so chaotic. And we've got really good documentation and guides on the RoboMaker site to get going on it. I don't know if you have any other advice for beginners, Jeremy?
Right, so my favorite starting place, we go to ROS.org. There's a turtle set of sample code. That's the best place to start. It talks through ROS topics and nodes and describes ROS kind of development architectures. So that's a great spot to start. Another interesting robot, and Ryan, you brought up a couple great robot platforms that are really inexpensive. In particular, the JetBot, I think, is like $250 all in. And so there's some inexpensive robot platforms out there. Great place to get started. But there's also one with the Husarian ROSbot that what's nice about it is it comes with a RealSense camera. It has a LiDAR. It has all the core components that a productionalized robot would have that are usually much more expensive. I think it's about $1,400, $1,500. But if you're really serious about this, I think it's a good investment. And they have a ton of great content on Husarian's website on different types of robot interactions and things like navigation and object detection and object avoidance and those types of things. And there's actually a RoboMaker tutorial that they've created that works with their robot. Having said that, it costs $1,500. You can also run it in simulation. So that's what's kind of cool. Is you don't need to spend that money unless you want to get hands-on with it. You could run through Husarian's guide, and there's actually a link on RoboMaker or AWS or aws.amazon.com/robomaker/resources. If you go to the resources section, and then you look at the blogs, you'll see the Husarian guide. And what's nice about that is you can learn about some of those those development paradigms. You have some great content there. That's the only thing I'd add.
So
Awesome.
the request is, do you mind, Jeremy, dropping the name of that into the chat or a link just so people can go look it up?
Yeah, absolutely. I'm going to go grab the link right now.
Okay, cool. Okay, one more question, and then we'll do the raffle because we are over time.
Yeah.
So the question is, can ARM-based hardware be simulated like the Raspberry Pi?
Yeah.
So, yeah, go ahead, Jeremy.
Okay, yeah. So as of today, the RoboMaker service doesn't support ARM-based hosts. It's kind of cool. EC2, which is AWS service to run virtual servers in the cloud, does support ARM-based instances. However, our RoboMaker service doesn't at this time. Having said that, you can run ROS on ARM platforms. For example, the NVIDIA Jetson Nano is an ARM-based hardware platform. So ROS and Gazebo and all those tools work with ARM. So you can absolutely build and simulate your applications. Just in RoboMaker at this time, we don't support ARM hosts.
Okay, thank you. Okay, so moment we've all been waiting for, the highlight ever since the music, of course, which was the real highlight.
Drum roll.
I really want to clarify, I didn't pick that music, by the way. I just went on Amazon Music and did background music. Okay, so the winner of the $200 value OpenDDS class, which is happening next week, is Joshua Frank. So Joshua, I am gonna drop my email into the chat here so that you can contact me, because I don't have contact info for you, or you can chat it to me. Whatever you want to do. I'm going to put my email right here so we can get in touch and get you signed up for that. And thank you everyone for joining. I know this was a different way of doing meetups, but I really enjoyed it, and I hope you did too.
Yeah, so I'd just like to say thanks to Jeremy and Ryan for participating in this. We had originally scheduled this to be a in-person meetup, and unfortunately we weren't able to keep that, but we really appreciate you taking the time to put this together for us. And it was a great presentation. We'll have this available, the video at a later time, and so keep an eye out. We'll have that posted whenever that's been approved by AWS for publication. So.
Great. Thanks, everybody. Thanks for attending. Hope you learned something today. And go check out RoboMaker on AWSAmazon.com/RoboMaker. Thanks.
Bye. Thank you.
Bye.